So we've already got a lot of practice solving inequalities and equations, and now we're adding in absolute value equations and inequalities. So that's involving that absolute value that we may have seen before. So we're going to look at this question together in class, kind of illustrate this concept a little bit more. But in this question, what we can do to basically refer to the distance from Serena to Darius, if she's skating over and she skates eventually past him, her distance is going to decrease as she skates towards him, and then as she passes him, it's going to increase. So we're going to use absolute value to model things like that. We're going to solve absolute value equations and inequalities first by isolating the absolute value expression, and then we're going to write an equivalent pair of linear equations or inequalities. So again, still isolating just like we have with some of those earlier equations. And we haven't actually seen an example yet, so we'll just look at this example together when we're doing a practice. If I want to solve this as an absolute value equation, again, I don't have an inequality symbol, so just equals means it's an equation with an absolute value sign. If I'm going to solve this, again, I have to isolate the absolute value expression, which means not just the variable, but I have to get this absolute value symbol by itself, and I can do that by adding 5 to both sides here. If I had negative 5, I can cancel that by adding. So if I do negative 2 plus 5, I get 3. And then what this means is if the absolute value of your variable n is 3, that means that n could either be 3 or it could be negative 3, because absolute value just refers to on a number line. So when it asks us to graph it, if I use positive 3, that's a distance of 1, 2, 3 away from 0, and the distance away from 0 for negative 3 is also 1, 2, 3. So in terms of geometry, that's what absolute value means. It's how far you're going away from 0. So 3 or negative 3 both work because we're both going same distance in either direction. And basically what an absolute value symbol does is any number that you're going to put inside of it, so 3 or plugging in a negative 3, any number that's inside becomes positive. So remember, absolute value makes things positive. So looking at that with our first example is just n by itself an absolute value. And I'm going to skip past, I think, reading this paragraph. And I'm just going to kind of show what this looks like if I have something besides just x by itself or n by itself. So now if I have an expression, 2x minus 5, again, your steps are still the same. We still want to isolate the absolute value, so this is isolated. I don't have anything else on the left-hand side. It's just absolute value and then equals 13. So what we have to do, just like what we did in the last question, is I have to separate that into two possible answers. So 2x minus 5, this absolute value part could either be a positive 13 or it could be a negative 13, because if everything in here simplifies to negative 13, absolute value of negative 13 is also will be positive. So first step to get rid of your absolute value signs is you're going to break it up into two different equations. And now that I have my two different equations, I solve those like usual. So add 5, divide by 2, I get x is 9. Same thing, add 5 and divide by 2, we eventually get x is negative 4. So absolute value will often have two different answers. We could have negative 4 or 9 would both work for x there. So generalizing that, again, if I'm just putting that in terms of any numbers, if I have anything inside of absolute value, again, if I want to solve that, I have to solve two matching equations where a is equal to b or a is equal to negative b. So again, we want to first isolate it and then just make sure we solve it when it's positive and solve it when it's negative. So looking at this word problem, it's kind of like that question we saw at the very beginning. Starting from a certain distance away, your friend skates towards you and then passes by you at constant speed. Her distance d from you in feet after t seconds is given by this equation. So we have a distance equation with absolute value. What does the 80 in the equation represent? What does the 5 represent? And what times is she 60 feet from you? So answering that first question, what does the 80 in the equation represent? So that just represents that if you start at 80, that's the starting distance, and we're going to be subtracting from that, because again, we're taking the 80 and we're moving towards that distance first. So we start from 80, and then the minus 5, so what does the 5 represent? That represents skating 5 feet every second. So if I skate 5 feet every second, every time I increase the second, so if I increase the time, that's going to be taking 5 away from that distance as I get closer and closer to 80. So if I want to find out at what time she's 60 feet from you, I'm not plugging in 60 for the time, I'm plugging in 60 for the distance. So I don't know 60 seconds, but if I want the distance to be 60, I'm solving this equation. 60 equals 150, or sorry, not 150, absolute value of 80 minus 5t. So I've taken that equation and I've plugged in the 60 for the distance. And remember, that just means that if I have an absolute value and I want to solve it, I got to get rid of absolute value by breaking it into two equations. One where the absolute value part, so 80 minus 5t, is a positive, so positive 60, and one equation where 80 minus 5t will be negative, so negative 60. Once I have those two equations, though, I use those same steps from earlier to solve them, so it looks like I subtract 80 and then divide by negative 5. No switching here because that's just equals. So I get 4 seconds for the first time, and subtracting 80 and dividing by a negative 5 in the second equation gives you 28. So we see that if I skate towards him, if I have two friends skating towards him, I'll be 60 feet away at 4 seconds, and then later on you'll have passed them and gone 60 feet past them at 28 seconds. So next, we're recalling that absolute value represents distance from 0 on a number line, so just what we saw on that last page. Distance always has to be positive, technically not positive, just not negative, so it could be 0. So any equation that states the absolute value of an expression is negative, it's going to have no solutions. So we see that in this next example. If I am given my equation, interrupted by a bit by that bell, but if I'm given an equation with absolute value of 3x minus 6 minus 5 is equal to negative 7, first thing you want to do is to isolate the absolute value. So I'm going to do that by adding 5 to both sides. So I get the absolute value isolated. But once I've done that, negative 7 plus 5 is negative 2. So if I see that my absolute value is supposed to be equal to a negative, we know that can't work. So as soon as you see that, you don't have to keep solving. I just see that the absolute value is equal to a negative, so our answer is just no solution. And just like what we saw in the last section, we can still use compound inequalities. And the difference there is how the absolute value is written with less than or greater than. So we're going to write that as compound inequalities with those differences. So if I write in this first example, the absolute value of n minus 1 is less than 2. If it's less than 2, you want to think it's within a distance. So what that really is going to mean is that n minus 1 has to be more than negative 2, and it's got to be less than 2. So again, if I'm starting at n minus 1, it's got to be either adding 2 or subtracting 2, but I can't go any further. The difference there is if I say greater than, n minus 1 absolute value is greater than 2, that means it's got to be at least a distance of 2 away. So last time we said the distance has to be less than 2, and next equation is like saying the distance has to be bigger than 2. So that means n minus 1 is going to be either less than negative 2, so going 2 backwards, or n minus 1 is going to have to be greater than 2, so going at least 2 forwards. Now let's see what that looks like with a little bit more generalization. So again, if you see anytime an absolute value is less than a value, that means it's basically going to be an AND equation. So negative b is less than that value, and it's less than b. So we break that into an AND, and remember your graph should look something like that AND solution as well. So I have within a certain distance. If I won't have an absolute value though that it's positive, or sorry, not positive, but just greater than a certain value, so absolute value that's greater than, will be going at least a certain distance away. So it's going to be looking like an OR graph. So if you want to tie those back to the last section, absolute value that's less than is going to be like an AND graph. Absolute value that's greater than will be like an OR graph. We see those two examples there. So looking at that first practice question, as soon as I see the absolute value 2x plus 4 is greater than or equal to 5, remember if I see absolute value is greater than something, that's going to be an OR graph. So the first thing I want to do is to break my answer up into two pieces, but also making sure to leave that OR in there. So I'm going to have greater than or equal to 5. And then when I say OR and I use the negative, remember that means we're going to have to flip the sign. So if I say my second inequality, it's not going to be an equals, it's going to be less than or equal to negative 5. Once I have those two though, I still follow my same steps. So subtract 4, divide by 2, I get x is greater than or equal to 1/2. Subtract 4, divide by 2, I get x is less than or equal to negative 9 over 2. Since those were OR, remember you're going to go in two separate directions. So if I graph that, x is greater than or equal to 1/2, goes it off to the right. Or x is less than or equal to negative 9 over 2. So negative 9 over 2 is here, and it goes off to the left. Making sure that these are filled in because those can be equal to. So last question, or I guess last two questions, is we're solving first for our word problem. And if I start with a 32-ounce box of pasta, again, we know not every box is going to be exactly 32 ounces. So if I want to show the allowable difference from that ideal weight, and when I say ideal weight, that's what we mean by the 32, is at most 0.05 ounces. We have to use that to write in an inequality using absolute value, and then find the range of allowable weights. So as soon as I see at most, remember at most is going to mean less than or equal to, so I can't go over 0.05. I can be less than that or equal to it. And when I'm finding the difference from the ideal weight, again, difference is subtraction, so any number that I use minus my ideal weight, so if I go a little bit over or a little bit under, if I find the difference from the ideal weight, the absolute value of that has to be within 0.05, because I can't go any further or else it's not going to be close enough to my box of pasta to sell it. So again, as soon as I see that absolute value is less than, we treat it like an AND inequality. So I'm going to just write that into my AND inequality where I have 0.05 greater than, just like it is in the inequality, but also a negative 0.05 that's on the other side of that x minus 32. And we're able to get rid of absolute value because we set it up with our two directions. So I can be greater than or less than. And all I have to do to solve this here, I have to isolate x. So if I add 32 to all of my parts, I can solve it and just get that x has to be in between 31.95 and 32.05 inclusive. So those weights will work. So they're not quite 32 ounces, but it's pretty close, good enough to sell for our pasta box. And last one is just asking us kind of conceptually, if I had this inequality, w minus 213, the absolute value of that, if that's less than or equal to 5, could we first add 213 each side? And that's a pretty common mistake, is people see that minus and they want to get rid of it. But we actually can't do that first. Remember, whenever we have an absolute value inequality, that means we have to first rewrite it. In this case, since the absolute value is less than, we're going to rewrite it as an AND inequality, where I have that the absolute value is less than 5, but also the absolute value, w minus 213, got to be greater than the negative version. So it's got to be in between the negative and positive 5. So we eliminate that first. Afterwards, then we would add 213. So make sure we have these notes in. We'll try some practice in class.